Hi all, my name is Doris France and I am bringing you a lesson on debugging. This lesson is called Introduction to Debugging. It's a general debugging class that applies to all languages, but I will be using C# as for examples because I'm primarily a C# developer. So let's get started. So the scope of this class is general debugging, the importance of debugging, when to debug, debugging challenges, debugging strategies, examples using C#. What is debugging? There are lots of definitions out there, but it boils down to debugging being a process by which a developer identifies, reproduces, and attempts to solve defects or errors in computer programs or computer hardware. Okay? So in this lesson, we're going to focus on software debugging. And I want you to know before we get started that debugging can actually be a lot of fun because when you actually solve problems or issues or bugs, you get a high, if you want to put it that way. So it's exciting to debug, especially if you're debugging someone else's work, not issues that were caused by you. And then when you debug your own code, then you're like, what was I thinking? But ultimately, you get joy in knowing that you solved a problem. Why is knowing how to debug important? Debugging is probably one of the basic skills that each programmer should have because ultimately you want to solve problems and you want to do that in a very, very quick manner. Uh, if you can turn around the debugs that, I mean, if you can turn around the bugs that you find into solution in a timely manner, this is very important, especially when you are in a world where mistakes or bugs can be costly. You want to be able to turn things around quickly. Okay? And also, you want to solve the real problem. Sometimes when you debug, problems can mask themselves, and if you're not sure exactly how to debug, you could end up either adding um, more bugs by trying to solve one bug, or you could end up not solving the actual issue. So it's very important to know how to debug for that reason. Okay, so this is fun. I found this online and I thought that, I should incorporate it into this lesson, but this is just, you know how people, when they go through grief, they have stages of grieving. This is basically 6 stages of debugging. So the first thing we say that can happen, or we'll say something like that doesn't happen on my machine. As developers, we develop in our own local environment before we put things out there for other people to either test them or see them. And so our environments are always perfect places for us to develop, and so sometimes we can mask issues because of that. So we would say it doesn't happen in my machine, but that doesn't mean it doesn't happen in another machine. And we would say something like, that should not happen. So again, it's happening. What's the point, right? And then, or we'll be in denial about it and say, no, that's not happening, but it is actually happening. That's why it's reported as a bug. And then we get to a point where we say, okay, we've denied it all we could, but the bug is still there. So we then accept that we have an issue. And then we would again try to backtrack and say, but how did it work before? We ask all these questions because we can't believe that our perfect code has errors, but that's part of development. That's part of being a computer programmer. And for when you know how to debug and you know how to prevent those problems from happening, then you won't have to go through these stages too many times. Okay, so now when do you debug in the development life cycle? So as you already know that there's a software development life cycle. Each development that you do starts from understanding what are the requirements. I mean, there are other software development life cycles out there that are more extended and more detailed, but these are the basic steps, okay? And then once you understand what the requirements are, then you have to design, or some architecture will design a what they consider a perfect solution, and you start developing, okay? And so when you start developing, you should always start with understanding that you have to incorporate debugging from the beginning. That means that during development process, you try and prevent as many bugs as you can to begin with, and make sure that your logic is correct, or because nowadays it's very hard to have syntax errors, in that we develop with IDEs, which means that our code won't compile, right? So that's kind of eliminated as a problem. But we may have runtime errors, and we may have logical errors, and at that point, or we may have resource errors. So there can be all sorts of exceptions. So we want to make sure that we write our code in a way that prevents that. And also we can put logging statements as we are developing, so that we don't have to come back and do that. And also, during development, we can write unit tests that allow us to test the small units of code we have already created. So during development, we can start the debugging process. During testing, your QA people will most likely, if you work in an environment where you have separate testing people, they will do a very thorough job in vetting your work, and they will discover bug. That's their job, and that's what they do. And they will create logs for the bugs, and then you have to solve them during testing, and then they will the testers will send all that you've developed and has bugs back to development, and then you develop it again, fix all those bugs, and then it goes back to testing until everything is good. So now you go to production, and your stuff is out there in the field, but sometimes issues can happen, and again at that point you can debug based on the strategies that I will be talking about in the next slides. Okay, so what are the debugging challenges? Sometimes we can have expansive, huge applications that makes it difficult to debug, because they're just such monsters of applications. And sometimes we can have development environmental issues, like some OSs are easy to debug and some are not, and depending on the tools that you have, you might have challenges, or your understanding of the environment you work in, you might have challenges. And we have multi-tier applications nowadays. We have what we call distributed applications. So it's no longer one program that starts from finish to the end. You have web services, database accesses, all those things, web services especially. Your application relies on so many things that you don't have control over. So those are some of the issues you can face. Dependencies like existing DLLs, or missing parts of the DLLs, or missing DLLs. So there are so many reasons, or just that you don't have enough the right tools to debug. That can be frustrating as well. And also errors that appear. Let's say you are calling a web service and someone wrote and didn't pass you back the exception as it happened. They decided to manage it and send you either something friendly, and you end up thinking that that's the issue, whereas the issue is something else. So, but ultimately, here the issue you're having is that you have no control over what's happening out there, or things that your application depends on, and you really have no control over. So, what are the debugging strategies? And tracing. Um, Tracing to me is probably the best way uh, to to debug your application, because with tracing you can know exactly how your application executed from the beginning to when it gets to an error. So you have to trace your application. By that I mean you have to log the execution of your application. And again, depending on the logging tool that you are using, if you have written your own or using something that's out there that's available, you can have different levels of logging, things that are critical, fatal, error, warning, info, verbose. Verbose is basically just everything you want to put out there that could help you solve a problem. Okay, another thing, during development, and also tracing is a valuable tool in production when your application is no longer under your hands and it's out there being used in the field. You can access the logs and in that way be able to know exactly what happened, and then you can take that trace into development and say, okay, this is where I had an error, so let me go look in my code and see where I wrote this statement. So it helps out. So another thing is, during development, you can use debugging mode as well, where you step through the code. So stepping through the code is the best way to really see what's happening with your application, because you will be able to see line by line, okay, this variable has this value, my application went from here and jumped over there. All those things can be caught with stepping into the code. Also, in C Sharp and in many other languages out there, there's a way to do try catch blocks, basically, where you catch specific exceptions, and understanding the hierarchy of exceptions is very, very important, because then you can handle each exception the way you want to handle it, especially in applications where you there's user interaction. You don't want to you don't want to just put, like, the whole stack trace out there. You want to handle your bugs gracefully. So using try catch blocks is a way to allow you. And also, in your catch, you can there again log statements, which will allow you to see exactly what happened. And the stack trace tells you exactly what line where something happens, and you can drill into inner exceptions, because sometimes exceptions are a result of some other exception that was thrown by some part of your application. So that inner exception is really the cause, not the outer exception that you see. And then you have to evaluate the stack trace to see line numbers and stuff like that. And this may be specifically to C Sharp and some other major languages out there, but it's pretty much the same concept. As I said before, you can also use unit testing to test portions of your code that are critical. Sometimes, I've found out, to be honest, to be the best way to prevent errors by making sure that every unit of code is tested in a way, especially things like files or logging, all those things, or even just, like how your application would handle errors. You can, through unit testing, you can be able to make sure that those things don't happen. Also, when debugging, sometimes you get errors that you like, okay, I have no idea what's going on here, or there's nothing that's clear or that jumps out, or or you've done your due diligence and you still cannot figure it out. So you can ask your peers online in the office and ask them, hey, have you seen this? Most likely they have, especially those who are more advanced than you are. They probably have seen it, and or they will know a quick and easy way of solving the problem. You could also go to the internet and type in, usually the message in the exception, someone has searched for it, and you can use resources like stackoverflow.com. You can use resources like that and just enter the message. In fact, I do encourage you to create a user profile there if you want to, so that you can be able to have access to all those resources that they provide, their users provide, and you can also contribute when you know how to solve an issue. Now we're going to talk about examples. Here is an example of a code that looks perfectly fine, and it looks like everything, like it wouldn't fail. But if you look at this code, we've created an object here that is a list of persons, okay? And our list is initialized so that, like there's no null reference, okay? And then we then take that person's list and we search for a name Lee, okay? And then we try to write that out into a console. The issue there is that if person is null, your application will blow up. So you won't be able to it will fail, and you have no catch try catch block there, so your application will just blow up ungracefully. This is an example that shows a try catch block. As you can see in this example, I use the same example, but instead I caught a specific error message, and in this case I could have written that this was a null reference exception, so that I know just by looking at my output in the console.writeLine or in the e.toString, it will tell me exactly what happened. So again, another example with tracing, and you can see here that in my console it wrote that it created a list of persons searching for person Lee, and then it failed right there. So again, it shows that with tracing you can know exactly where your application blew up just by using the statements that you put out on either in a file or in whatever output method you want to put it. You can put in a database, you can put them anywhere you want to store your logs, so that when an error happens, you know exactly where it started and where it ended. So again, I will be adding some YouTube presentation to show the stack trace, and to show some examples using C#. Thank you so much for watching. Don't forget to share, subscribe, or ask questions as well. If you subscribe, you will get a notification for future videos.